Hi, today on the channel I'll be working on this Sega SC-3000H. H stands for keyboard apparently. Come join me. Okay, so here we are on the bench with the SC-3000H, and yeah, this is it. So those of you that are familiar with the SC-3000, this is, well, it's the SC-3000H, and the H, I don't know why it's a H, but it's the one that has the nice keyboard. I've grabbed out my regular SC-3000, which is this one, and as you can see, the keyboard is this rubber membrane, which can be a little bit annoying. Thankfully in mine it didn't need any cleaning or anything, it just worked, but other ones have been a bit trickier. Otherwise, they're basically the same. It's got the same keyboard layout, the keys, the power switch, everything else, as far as I'm aware, is completely compatible between the two. You can even see that they have the same connectors on the back, power switch, power input, there's the cassette in and out, we have the printer port, the video, there's the RF setup. Obviously on mine I've removed the RF, but the stock one does have it there. This one, it was sent in by a friend of the channel. You might be familiar with a couple other things that he sent in. Recently he sent in the PC Engine with the Super CD squared, 2 squared thing. He's just sent this in for repair as well because he said he got it recently and it just shows absolutely no sign of life. So yeah, let's dig into it. I've got my copy of Load Runner here that goes into the cartridge port because these SC-3000s, like I've covered in previous videos on the channel, do not have like an inbuilt BIOS or like a pre-built game or DOS or anything like that. There's no basic, everything is cartridge. Without a cartridge, it just does literally nothing. So let's plug that in. Also plug out video in, and let's make sure we plug into the video port because I've made that mistake in the past because I'm used to Commodores where the Commodore port is on the right and the serial port is on the left. In this one, video is on the left and the printer port is on the right. And then we'll get some power. So I'm going to feed it 9 volts, and if I remember correctly, it is center negative. And well, let's see what we get. Flick power, we get a power light, and no signal whatsoever. Let's look at our, oh, okay, so we are only drawing, 11 milliamps at 9 volts. Yeah, you can see the little blip on the graph over there on the left. So normally in regular operation, these would pull somewhere around 600 to 700 milliamps. They're actually pretty thirsty. 11 is a bad sign. It's probably about as much power as it takes to run that LED. So definitely something wrong. Let's dive in and check it out. Now, I think pulling these apart should be pretty much the same as the regular SC-3000. So I'm going to pull out 3 screws on the very bottom here. And then the keyboard should be able to lift up and out. Yes, revealing the insides. And then this guy, which is it's like a shield thingy, will have some pryability from underneath there. So let's get up and under here with the pry tool. Yep, that breaks that clip. And then the other side, same. Yep. And then once that's there, we want to be careful because there's little pivot thingies here. You can see the 3, you can't really see. I'll try to brighten that picture in post, but you can see the little 3 thingies there. They are pivots out like that, and you can see the little teeth on all 3 there, and you don't, oh, this one, see, this one's already been broken. So someone has been in here in the past. Yeah, that sucks. But, well, anyway, that's how you get those apart without breaking those. So, let's take a look then. What I'm going to first of all do is just remove this keyboard because I hate these connectors. It can be a pain. Let's get that out of the way. Oh, okay, so that has something wired up here. See, in the previous one, well, in my one, I should say, the LED, I guess. I'm not sure where that's coming from. I think that's what that wire is going to be. That was transmitted by the regular cable. By the way, let's remove it. There we go. All right. Pop the keyboard off to the side. And let's take a look. In general, it looks pretty clean in here, actually. Can't see any obvious failed points. None of the electrolytics look like they've let go of the gunk, which is good. Same on the video board. CPU down here, we've got the MyTech, that's the big gate array that runs the thing, and then we've got our 88128, I believe that is our system RAM. Underneath the video board, if we take that out, we will see we have our input-output controller, our peripheral controller that takes the input from the keyboard and transmits it to the CPU onto the data bus. And we've got our video controller. This is the TMS 9929ANL. And then we have a bunch of video RAM. So these are 8118. I think I've covered basically the layout of the main board and how the circuit in general works pretty well on my channel previously. I think I'll pop that link up in there where I repaired my unit. Let's see where that power's going and why it's going nowhere. So if I pop this in voltmeters mode, switch that on, 9 volts is definitely going across the fuse. So we've got that. The switch is showing continuity because we were getting the LED before, that's fine. Are we seeing power on this capacitor? No, okay. So it's getting as far as the fuse. It's getting to the switch. Getting to the other side of the switch, and it seems to be dying there. I think I need to take this board out of the thingo, out of the case, and have a look on the underside. Now, unfortunately to do that, as I've shown in my previous video, I do need to desolder the power switch because it does hold it in place. So let's do that really quickly. What I'm going to do is I'm just going to flow some fresh solder on these pins and bend the leg of the switch out of the way. Okay, I'll just use my little pry tool here to get in between. Okay. Well, looks like someone has made a mess in here before. Look at that. God, look at all this junk coming out. So much old solder. Okay, so switch is now disconnected. So we've got a couple of screws holding the board down. Let's get those out. There's one here, and I believe there's one under here somewhere. Yeah, there it is. The board's also pretty dusty, so this will give me a good opportunity to give it a wipe down. Okay, now I need to pull it out, and that way because the joystick ports kind of hold it up in the shell here. So there we go. All right, seems fine, looks okay. I wonder if our 7805 has died. Very good question. What I'll do, just take a little bit of solder and wrap it around the two legs of the power switch. Ta-da, power switch. And then let's give it some power. Still taking no volts. So we should have power and ground there. So this should be our power input. There's our 9 volts. And do we have 5 volts? No, we do not. So there it is. Now, 5 volts in, nothing coming out. Wow, hopefully that one's pretty simple. Dead regulator. Okay, let me go grab a new 7805 and we'll pop that in and see what we get. While this built-in regulator and the system in general only takes, I think it uses up to about 1 amp of current, and the 7805 here, they're good for up to 1.5, I believe. The modern replacement would be a 7805, and I have the 7805, I don't know if you can read that, 7805 CV. So these can also take up to 1.5 amps. What I like to do is go a little bit over and above. This is the 78S05 CV. And these are rated up to 2 amps, so they provide just that little bit of extra, longevity, especially because the 5 volt regulator in this is driven pretty hard. I just wanted to not wear out, and the price difference is bugger all, so why not? Alrighty, now let's avoid desoldering this while it's still attached to the heatsink. Just pop that screw out and just give it a quick lifty lift. And then a little bit of fresh solder on these 3 pads. And if we grab our tweezy boys, we should just be able to pop that off. All right, now I'm just going to clean up those pads because, you know, there's old solder on there. Let's make it nice and fresh. And let's also just clean up the old heatsink gunk. As well. Pop a new little bit of, what is this? This is ancient Arctic silver that I've got lying around. Pop that on the 705 itself. Don't need heaps, so it will spread pretty nicely. And what I'm going to do is I'm just going to place that on board first. When did it go in? Went in that one. And then I'm going to put the screw back in, and that will align those pins ahead of time. We don't need to worry about alignment. What I do need to worry about though is bending them down a bit. So I'm just going to, there we go. All right, let's do it. Beautiful. Final cleanup. Alrighty, let's give it another test. Now we've got the power switch locked on, so that's fine. Let's see what happens when we power on now. Alright, we are drawing a decent amount of current. Still no video though. How interesting. But yeah, we are drawing 640 milliamps, so that's a better sign. But no video output. Didn't have my speakers on, so I've just turned them on. Now I can hear. Let's try it again. No video still, but we should be able to hear game sounds maybe. Yes. Yep, definitely. So the game is running. You can hear the sounds. We're not getting video. Narrows it down. So that rules out quite a lot actually. Rules out the CPU, rules out the MyTech, it rules out the system memory, rules out the peripheral controller. Just points directly towards the video controller, the video board, or the video RAM. So let's dive a bit deeper. Now, one thing to note that I just noticed while I was thinking about it is we're still not getting composite video sync, and let's prove that while I'm here. So I think I'm going to pop my oscilloscope on and let's probe the video out signal and see what we're getting. The easiest way to test, and I know how it works is in this instance, is because my system says no signal, that means it's just not detecting that composite video sync. But let's prove it using the oscilloscope and we can see if we're getting a composite video signal. Okay, so I'm back. I've got the scope set up. I've got it set to 500 millivolts per division. I moved it all the way down because from experience with this board, the composite signal is at about 3 volts and it's about 1 volt peak to peak, so it should be somewhere in the middle if we're getting anything. I don't think we are. And just on the schematics that I've used in the past, if we have a look here, this is the area that we're familiar with. This is the video signal, the TMS 9929 AML, the video processor, I should say, the video chip, the VDP. And then there's this connector here, which is this one right here, that goes into this mod board, which is this board here. And this is what actually takes the Luma, or the Chroma, I can't remember exactly, the Y, and then the RY and the BY, which are the different signals, and converts it into composite video, and then outputs it back to the board so that it can go out the video connector on the back here. So what we're wanting to do is, first of all, we want to look at what is on pin 6 here, because that is our composite video pin. So thankfully it is numbered, it's 1, 2, 3, 4, 5, 6. So what we'll do is we'll pop it on 6 right there. Signal's ready, we're in good mode, and let's hit power and see what we get. Nothing. It just sits, it gets a bit fuzzy, but it just sits down at, really at 0 volts, flaps about. We're still getting sound. No. Interesting. Are we on? Yeah, we're on. Oh, no, there we go. Yep, okay. Sounds very weird. Not sure it's particularly healthy, but yes. So the next one that we want to look at, we're not getting composite signal. So we don't know if that is because the video board itself isn't processing those signals, or if the VDP isn't giving us the video signals to actually process. So what we want to check next are the RY, the BY, and the Y, which is the 3 video signals, and see if we're actually getting something out of the VDP to process. So those are on pins 1, 2, and 3. So let's power back up while we're checking pin 1. Oh, yep, there we are. So there, that looks like a, still very fuzzy, but there is a signal there, and it's bouncing around. That looks good. Same here. Oh, and there's a good signal. Look at that one. Oh, you can actually see. So that, yeah, okay, let's turn that off and turn that back on. Yeah, so that is an actual composite field. That is from the lower signal there is the vertical sync, and then in each, this is every single line being drawn. Yeah, and you can see as it's drawing those lines, we're actually seeing different data values. So I think we are actually getting a good, a good signal out of the VDP. And for some reason, this video board itself just isn't converting that power, converting that signal across to composite video so that we can actually use it. I think we need to take a deep dive into this video board. So let's do that. Okay, so this is our video board. Now, just having a quick look over, I can't see anything really exploded or obviously damaged. Even just looking on the back, like there's no traces. The board isn't cracked like my previous one was up here. Yeah, nothing looking horrible. The only thing that I can see is that right down here at the base of this capacitor, the board is a little bit scorched, and the same thing at the base of this resistor over here. I don't know if that's coming through at C115 there. There's a little bit of scorch marks there, but the components themselves look okay. It doesn't look like anything's leaked. Based on my experience with these though, these two transistors here, what are they? They are TR 106 and 107. Let's have a look on the schematic here if we can find them again. And they are down here. They are part of the actual switching. It's TR 106 and 107 there. They take the brunt of work here in it's effectively a voltage divider circuit. I can't remember exactly, but it takes the 9 volts from here and converts it down using the transformer, and it's a rudimentary switch mode power supply, blah, 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 blah. There was a full explanation in the previous video that I did. Go check that out. But yeah, they do a lot of work, and if they don't work, then we just don't get the correct voltage out that the rest of the circuit needs. So I think what I want to do is possibly check the outputs of this to see if we are actually getting good voltages. which would indicate that those transistors are actually functioning and providing power to the rest of the board. So let's clip that back in. Let's pop our little clippy thing on the end of our scope. And what we can do is we can clip onto one of the leads of those transistors and see what they're doing. So let's take a look at, what I want to do is actually look at the output of this inductor here, L104, because that's where our voltage comes out. So let's find that. It's either that or the top leg of C119. Let's find one of those. Now that we've got that connected, let's check the scope when we power on and see if we're actually generating correct voltages. No, so that's staying at, which means the power supply board part of this, the voltage circuit, isn't actually generating the voltage needed by the rest of it to actually convert to composite sync. So I think at this point, one of those transistors has died. And I will take them out and we can give them a test and see if they're good out of circuit. Like I said, that's just based off my experience, but it does look like we're not getting that voltage regulation out of this little component, this little part of the board that is necessary. It runs all the other ICs and whatnot. So yeah, let's take out the top one first and we'll go down to the bottom one. If it's not that, then we'll have to figure something else out, but yeah. Okay, so we have, I guess it is a C-3000H, whatever that is. And that was TR106. It is a 2SC-3001. No, yeah, there you go. No or damaged parts. So let's try it on the bottom and reverse it just to be sure. You get a good connection. Bingo. So that transistor does not appear to be good, and we can do a double check with our meter in diode mode. Check between the pins. We are getting absolutely nothing. It is completely dead in all directions. Yeah, wow, look at that. We're not getting any readings whatsoever. No. Yeah, that thing is completely toast. So we need a replacement. I don't know what a C-3001 is. I did look into this when I was working on this previously, but I can't remember. So I'm going to go look that up and I'll be back in a second. Okay, so just going back to my old video and also just doing a quick bit of research as well. It looks like the BC337 would be a modern-ish replacement for that the C-3001, which is what I have here. Thankfully, I had some in my loose stash. So let's pop that in and see if we get something working. Now, I was also wrong in my recollection of how this board works. It's not a step-down transformer, it's actually a step-up. It's a non-isolating feedback transformer or voltage regulator. So it actually boosts the voltage in up to 12 volts that are needed by this down here, the LM1889N. So hopefully now it will work, but we don't know it until we try. So let's give it a try. Let's see what we get. Something, but not enough. And we're actually maxing out at 1.5 amps now. So my, oh geez, that is scorching. My benchtop supply went into current limit mode and that did not work. So there's definitely something else going on here. Now, the last time this happened, it was because we had lost the oscillations from the whole circuit. So what was happening was it was just sinking current into that transistor and just, yeah, cooking itself, basically. That's how they burn out. So let's take a closer look at all of these connections. So what I'm going to do is I'm going to grab out the microscope and take a really good look. So here is the transformer. Those pins all look fine, nothing loose. Can't see any breaks. A whole bunch of junk flux and junk here. Like I did one of these, but I didn't do the other one, so it's interesting that there's kind of shiny solder on all of these connections. Doesn't look like there's any bad joints. I'd expect maybe a break somewhere. Cracked solder joint or something, but no, everything looks fine. There's that scorch mark that I mentioned earlier underneath this capacitor. So this area here is really scorched, which means it's gotten very, very hot. And we should also test that this Zener diode is still being a diode. This is the other scorch mark that I was mentioning underneath this capacitor here. So it's fully cooked there as well. But we really want to focus up in this spot because this is where the problem would apparently lie. That's the transistor that we just replaced, and this one we haven't replaced yet. It is a C945. It may also be junk. There must be. If we. So what I'm going to do is I'm going to check these two diodes. This one here is a Zener, ZD10. Let's just make sure it's still being a Zener diode. This is the one that actually limits the voltage to 12 volts in the feedback loop. 0.6. And yep, no, that's fine. So that Zener is good. What about the other one right next to it? Yep, 0.6 as well. So they're both fine. So, something else. All right, maybe let's check that other transistor. Maybe they've both gone bad. Okay. Let's see what we get. 2 resistors. Yeah. Yeah, 2 resistors. So that one is also bad. Not a good sign. All right, let's just clean this up a bit. And let's replace that one as well. Well, I definitely made a discovery. Just poking around because I can't find a damn problem. And well, I was tracing this part of the schematic. So pin 5 on the transformer comes out, goes through this capacitor, which is C120, which if we trace that line up there, goes up to here, and this is the other end of C120, goes across C120 there, so that's a 22 nanofarad capacitor. And then from the end of C120, it goes into R1 something or other, which goes down this line here, and then through this 22 ohm resistor. I don't think you can see there, but that actually says 22 kilo ohm. It's supposed to be 22 ohms. That's a problem. So let's take that guy out. It's C130 here. So let's have a look. There's 22 and brown would be 0. So it is, yeah, 22 ohms. It should definitely be 22 ohms. Well, I mean, that's wrong. So let's see if we've got a replacement. What do we want? 22 ohms, 220. 220, I've got more 220s. 2K2, it's 27, that's pretty close. I see 22. 22. You can't read that. 22. All right. Let's just double check the markings. They are, it looks like red, red, black, gold, brown. All right, give it some power. Aha! And we are no longer drawing total current. This is now, oh, that doesn't help though. Damn it. And straight back. Damn. I thought I had it. Nope. Oh, keep going. Well, this board clearly has some troubles. So what I did was I pulled my board, my video board, out of my SC-3000 that I showed just a minute ago, and I'm gonna plug this in and see maybe if we can just move on. We'll see what's happening with the main board. Go from there. So what I've done is I've taken the video board out of my SC-3000 and popped it into the main board because I want to just kind of move on and see if I can get a working unit, whether it's with my board or not. Put power, we've got video, we're recording. Let's hit power and see what we get. Okay, oh, so, it's mostly working. There's definitely some corruption somewhere. So that looks like memory or a data line is corrupt. Something's wrong still. So this SC-3000, let's turn that off. That would explain also why we were hearing that weird audio earlier. Definitely still something wrong on this board somewhere else, but that means that we're kind of at the wall of what I can do at the moment, and this is going to require quite a lot more work than originally anticipated. It's a pity it wasn't just that 7805, huh? Yeah, I think I'm going to need to take another plan of attack, do a bit more research, and just have probably a good looking over without the camera in my way. And I guess I might be back with a future part, trying to figure out exactly where to go from here. Thanks for watching.